Hey, what's up, guys? This is Sheng here. So let's take a look at last problem of this week's weekly contest, number 1681, minimum incompatibility. Um, this one is a medium problem, and a lot of people downloaded this problem. I don't know. I don't know about that, but okay, let's take a look at the description. So you're given like an integer array numbers and then integer k here. You're asked to basically to divide these nums into k groups where that, and there's a constraint that basically each group cannot have two duplicated numbers, right? And so that's the constraint to divide these k groups. And then it asks you to get basically a subset incompatibility is the difference between the minimum and the maximum value in this array here in each group, and it asks you to return the minimum possible total incompatibility of all the case groups. And if there's no way you can divide the into k groups, you just need to return -1, right? So I mean, for example, right? So the first one is like this. So we have 1, 2, 1, 4, right? So obviously, oh, and one of the constraints is that k is the length is divisible by k. So it's guaranteed that you can divide those numbers into k groups. And for example, this one here, right? So there are like how many ways to divide into a group of two, right? Size of two. Basically, that's a combination four of two, right? It's gonna be 4 times 3 divided by 2 times 1, right? Which is which is 6, I think. Yeah. But not all 6 is possible, is valid because, one cannot be to 1. So this one is not it's not optional. Basically, you can only choose from certain groups, right? So yeah, basically that's the description of this problem. I mean, a naive approach will be of course we can try to use a backtracking, I guess, right? And because the length of the number is only to the 16, we can try to use backtrackings, but I think if you use a regular backtracking, it will probably TLE because basically at each of the location at each of the numbers here, right? We'll try to pick uh we'll try to pick k numbers. We'll try to pick the next k numbers from the remaining unpicked numbers, right? And then we just continue doing that. I think for that, the backtracking time complexity will be similar to n to the power of k, and that will TLE of course, right? So and then another option is that we just try the DP, right? So basically we try the DP and DP the state will be like the picked numbers. Basically the state will be the how many numbers have we have picked so far, right? And then we can either use a tuple here, we can use a tuple, or we can just use like a mask, a bit mask, right? So tuple, which basically we just store the number itself, and for the bit mask, we can save some space complexity, right? And but we're gonna use the index, the bit mask to represent each of the numbers, and so 0 means not picked, right? Not picked. And 1 means picked, right? And at each of the state here, at each of the DP state here, we're gonna have find all all the non-picked numbers here, and then we're gonna do we're gonna do a combinations. We're gonna do a C of this number of not picked numbers. We'll call it M, and then we'll pick the target. We're gonna have like target. So the target will be what? So we need like the n divided by k, right? So this is going to be the target, call it target n here. So it's gonna be a target n for each group. So at each of the DP here, we just do a target, do a combinations from the remaining items, and then we pick this many of the numbers, and we do combination. We try each of them, and we'll get the minimum total sum among those, right? I mean, I don't know if there's a better solutions other than this kind of like a brute force DP solutions, but anyway, so let's try to implement this one. So the so a few things, we have a length of nums, right? And then we have a target, right? Target, or let's call it equals to k subsets. Let's call it subsets. Subsets size. How about that? So I think this is like more appropriate name for that. So subset size will be n divided by k, right? And then we're gonna have like the DP, right? So the DP, I'm just using a bit mask here, and then I'll also using this Python's built-in functions, right? So to help me do the top-down memorizations. And so here's a template, right? So the at the beginning we have the system max size, right? And then in the end we return the answer, right? So I mean the implementation is a little bit trivial because there's no other options but but I have to find, basically we need to find the remainings, the remaining uh, the remaining numbers which has not been picked, right? So here I use I for I in range n, right? Basically I loop through everything for, n, and I find if that mask is 0, right? So I use this one equals to 0. Basically this is like a short version of the for loop. So among all those kind of numbers, I find the index whose mask is 0, because 0 means it has not been picked. Because here in the end I'm going to do a DP 0, right? 0 means everything each bit mask is 0. So now I have a remaining, and then I just need to combinations. So for the combinations, I just use a Python's combinations helper functions. That's very convenient for us to find all the combinations, right? Otherwise, to implement the combinations will be kind of annoying. So here I'm going to have subsets of size, right? So now we have a combinations here. So, but I think the combinations we should have to convert it to a list. Otherwise, it's going to be an iterator here. And then for each of the combinations, right, in the and so for each of the combinations, like I said, not all the combinations are valid combinations because we need to make sure there's no duplicate numbers in each of the combinations. So I mean, um, an easier way to do it is that since we also need to get the maximum and the minimum numbers into the for this group, I'm going to convert them into the numbers like so I'm going to do a nums dot I, right, for I in C, because C we have index in the C here, right? And then I just convert them into a number here, into a number of list. And then I just also convert them into a set because that's the easiest way to find if there's any duplicated numbers into it. Because if there is, then the length of the current numbers will will be smaller, right, than the target, than the subset size, right? So if that's the case, simply continue, right? Because here, right, check if there is any duplicate number, right? And now I just need to have like a new mask because now since this combination is a valid one, so I need to mark those mark the bit for each of the index. Basically for I in C, right? And then the new mask equals the new. I'll do this one, right? So that's that. That's why I mark this index the bit to 1, right? And then we just have this answer equals the minimum of the answer, right? That's the actual DP part, and we have a new mask, and then plus what? Plus the difference for this combination, which is the max of current nums minus minimum of the current nums, right? So here I know this is not the most efficient way, but it will not affect the total time complexity, and so I just use this one just for simplicity here, right? And yeah, so how about the minus one, right? So here, so the minus one is pretty straightforward. If the answer is 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 not smaller, basically we only return the answer if the answer is smaller than the max size, right? Else minus one, which means that if we never find the solutions here, right? The the final answer, the answer will be system max size. Oh, sorry, I forgot about the base case, right? So the base case is what? The base case is that we have picked all the mask, right? So which means that if the mask is equal to the I uh, by this, right? If the mask is all one, then we return 0. That's the base case because right here, right, at the end, let's say this combo is the last four, or is the last few numbers we need to pick for the last subset, and then we'll have this one. But here we have a DP. Now the new mask here will be 1 1 1 1, right? There will be all one. So in this case, we should return like a 0 here, so we can get the final answer right correctly. That's why we need this final uh, exit point here, right? Cool. And like I said, for this minus one case, right? If we never find any valid case, right? And which means that the DP here. So the DP, it will return this one, the DP, as the maximum one, right? So sum of the DP, if there's no valid for loop here, in the end, the DP will return a system maximum size, right? And then in the end, the answer will be bigger than this one. So for that case, we just need to return minus one, which means that we never find a valid answer. Cool. Yeah, I think that's pretty much it is. Let me try to run the code. All right, so accept it, submit. Yeah, so it barely passed because as you guys can see, it's almost 10 seconds, right? Because the time complexity, right? It's pretty obvious, right? The time complexity is the what? It's the 2 to the power of n, right? Because that's the total states of this bit mask, and that's gonna be the 2 to the power of n, and for each of the bit mask, we have this for loop here, right? So the for loop will be hmm, yeah, actually the time complexity will be a little bit complicated because here we have n, but we also have this kind of combinations. So for combination is oh man, it's a c to the n of k of the subsets, right? Of the n divided by k. Yeah, and yeah, actually, I'm not quite sure how what is the correct time complexity for this. I think it's close to this one, but I'm not 100% sure because it's quite complicated. We have a combinations here, and for each of the combinations, we also have like this for loop here. Yeah, so for for the cut time complexity, I'll just leave it here. So if you guys have a better idea about this one, I would more than happy to know that. And yeah, as you guys can see, because the time complexity is pretty big, that's why the running time is not that good. But for me, I couldn't find another way to solve this problem. You know, all the other ways they all got TLE, and this is like more like a brute force way to solve this, right? Even though it's a DP, but inside each of the DP here, we uh we have a bunch of combinations and for loops, nested for loops, and blah blah blah. Right. All right, cool. I think I'll just stop here, and thank you so much for you guys to watch this video, and stay tuned and see you guys soon. Bye bye.